If your phone is not turning on or it's going to be restart, after turning on it shows error like this: charging error, battery temperature too low or too high, you're unable to charge, please contact our sales. Also, your phone temperature is too high, please remove the charger or switch off the phone. These type of errors due to be Batt ID and Batt thermal line. Now, what is Batt ID and Batt thermal line? How these line works? How to trace it? I'm giving you all information in this video step by step. So first we go to the diagram. So you can see here in this diagram there are 4 type of battery connector, starting with first 3-pin battery connector. You can see here it's a 3-pin battery connector. First pin VBat, last pin ground. In middle you can see here it's BSI. BSI means battery static indicator. Through this pin CPU takes battery information like how much battery charge at a time. Also, when you connect a charger, how much battery need current to charge full. This type of information CPU takes and shown to the display like a battery symbol. Right now, next you can see here there is a 4-pin battery connector. It's also VBat, first pin and last pin ground. In between Batt thermal and Batt ID. Now BSI become Batt ID. Batt ID means battery identification. Now Batt thermal line for temperature sensing line. Right, in some phones which use this type of connector, this pin is NC and some as work as a Batt thermal line. Now go to the third battery connector. These type of battery connector mostly uses in Android 4G phones. In this battery connector you can see Batt ID and Batt thermal. So these type of battery connector with a fixed battery phone. So Batt thermal line is a very important line because when your phone temperature is increased, customer can't remove battery easily. So battery swell or other protections, this line for important in fixed battery phones. Whether the battery connect or not, also battery info CPU takes through Batt ID line. Right, on Batt thermal, if your phone temperature is increased beyond to the limit, CPU sense and switch off the phone or shown to the messages like phone temperature is too high, unable to charge, remove the charger. These type of messages through Batt thermal line. Batt ID and Batt thermal line work on a divider circuit. Number 4, these type of battery connector uses in iPhone or 5G phones because there is SDA and SCL line, serial data and serial clock. These are I2C lines. These lines are also work as Batt ID and Batt thermal line. But I2C lines are communication lines. Communication between master IC and slave IC. In iPhone, you can't change the battery directly like Android. If you change the battery directly, the iPhone message pop up unknown battery, even does not show battery health. For change the battery in iPhone, you just remove the battery strip to the old battery and weld in new battery cell. Right, so these are all about battery connector. Now next, Batt ID and Batt thermal line. Before we go to the Batt ID and Batt thermal line, first we need to understand how divider circuit works. Right, because Batt ID and Batt thermal line working on a divider circuit. How divider circuit works? Let's see. This IC, suppose this IC needs 2.5 volt, right? But we have a 5 volt battery. So how we will give 2.5 voltage from a 5 volt battery, right? For this we can create a divider circuit. So we need 2 resistors in a series. We can call R1 and R2. I am having R1 in 10k value, same R2 had 10k value. Now R1 connected with the main voltage line, or you can say voltage in. So I am connecting the R1 in battery positive and R2 connected with the ground. So I am connecting R2 in battery negative. This circuit completes when voltage pass through this circuit, right? The output line will be emerge between R1 and R2, which have 2.5 volt, right? When voltage pass through this circuit, output line will be emerge between R1 and R2, which have 2.5 volt. Now understand one thing, please write it down. For divider circuit, the minimum value in resistance is in kilo ohm, right? Kilo ohm. Number second, if the both resistance had same value, in my case in front of you the both resistance had 10k value. If the both resistance had same value, output will be half whatever the input voltage. A simple formula. If I'm increasing the input voltage 5 volt to suppose or 10 volt, output will be automatically half. Now output will be 5 volt. Now if I'm increasing 10 volt to 20 volt, output will be 10 volt, right? Also, if I'm increasing resistance value, both resistance 10k to suppose 100k R1 and 100k R2, result will be same. If I'm R1 is suppose 70k, R2 is also 70k, result will be same. So how this divider circuit works? Next, in this picture you have seen 3 type of divider circuit with different resistance value. Before we seen same resistance value, output will be half. There is 3 type of divider circuit had different resistance value and different result. Overall input will be same 5 volt because resistance value is difference, so output result will be also different. Now I'm applying this formula one by one, right? Now voltage formula is voltage in multiply by R2 divided by R1 plus R2, right? Now voltage in is 5 volt multiply by R2, so 25. 5 multiplied by 25 is 125. If you have a calculator, please calculate yourself. Now R1 plus R2, 10k plus 25 is 35, right? The answer will be 3.5. Same here, 5 multiplied by 70, it's 350, right? Divided by 20 plus 70, 90. Answer will be 3.8. Number third, 5 multiplied by 10, it's 50. R1 plus R2, 25 plus 10, 35. So answer will be 1.4 volt. Right? This is how divider circuit works. But what is the logic behind this circuit? How this circuit works? What is the logic behind? You know formula, right? But how this circuit works? If you take a rubber band and pull it with both hands, you will see that it is the weakest point in the center. Same logic apply that in the divider circuit. We have two resistors R1 and R2. R1 connected with the voltage line and R2 connected with the ground. So whenever a resistor connected with the voltage line, it's called pull-up resistor. When a resistance connected with the ground, so it's called pull-down resistor. So what is pull-up and pull-down? I will explaining in another video in power section. So when voltage cross this circuit, pull-up resistor pull the voltage on high mode and pull-down resistor voltage in downside. So weakest point between R1 and R2, pull up and pull down between this point. First we talk about Batt ID line. Batt ID line works on a divider circuit. I'm already told you how divider circuit work, right? Now in front of you on your screen there is a CPU, power IC, a battery or a battery connector, right? The Batt ID line connected between battery connector and CPU, also connected to the power IC, keeping with a heavy resistance. Show you this Batt ID line connected with between battery connector and CPU, also connected with power IC, keeping with 200 kilo ohm resistance, right? In mostly cases it's 10k to 100k, but in this diagram we have 200 kilo ohm resistance because this diagram is belong to model number Redmi 9A, right? Now 1.8 volt on Batt ID line, 1.8 volt on Batt ID line comes from power IC. You can also call VIO volt. You can see here it is VIO.18 volt, not 18, it's 1.18. I forget the type point. So it's 1.8 volt, right? So I'm told you now. According to the divider circuit, we have two resistance. I'm already told you Batt ID and Batt thermal line working on a divider circuit, right? So according to the divider circuit, we have minimum two resistance in a series. So this resistance connected in the VIO line, it's called R1, right? Because it's connected to the VIO voltage. So basically VIN voltage in now 1.8 volt in this line. So this is our R1, right? Now where is R2? R2 is mounted on battery strip. Here you can see here two resistance, one for Batt ID line, one for Batt thermal line, right? Now this resistance, one side attached with the ground, other side connected with the Batt ID line, right? Now when we put the battery to the battery connector, right, or you can say when we connect to the battery to the battery connector, this whole line will become 1, right? So 1.8 voltage cross to the Batt ID line in battery strip. So this resistance, one side attached to the ground in a series like this 1.8 volt. I'm explaining this 1.8 line with a one resistance, right here. Now it's a second resistance on a Batt ID line, right? So in a series, what is a divider circuit? You have a minimum two resistance. R1 is connected with VIN voltage in, and R2 connected with the ground. Same here, R1 connected with the voltage in and R2 connected with the ground, right? Now when divider circuit works, or you can say when battery connected after, or PMIC, when you turn on your phone or you connect your charger, after power IC gave 1.8 voltage to this line, after connect the battery, divider circuit works, the output will be dropped in this point. When output will be dropped as soon CPU sense the battery connected, right? I'm explaining. So suppose 1.8 volt in a divider circuit in, now R1 is a 200k resistance, this one. Now on a battery mounted this resistance we can call R2 connected with the ground. Suppose this resistance also a 200k value, right? Then output will be half. I'm already taught you in divider circuit, when two resistance value same as each other, then output will be half. What is the input voltage? So we have input volt 1.8, so output will be 0.9, right? Before battery connected. If battery not connected yet, then when you check here, you will get 1.8 volt on a battery connector. Connect the charger without battery, you can check here 1.8 volt, right? After when you connect to the battery, this whole line become 1 after divider circuit works. So this 1.8 volt become 0.9 voltage drop after CPU sense the voltage drop according to the CPU battery connect, right? This is the whole concept of Batt ID line, how Batt ID line works. Now if this line, Batt ID line, had some kind of problem, open, short or break, how to fix that? I'm telling you step by step. Now first we check a diode value without battery, a diode value in battery connector, Batt ID line. After we check voltage for 1.8 volt, right? If you get diode value also 1.8 value, after that you can check this resistance near the CPU, on CPU line connect this resistance, open the resistance, or you can say remove the resistance. First check the diode value on CPU side. If you get diode value here, after check the resistance on meter, ohms mode, multimeter, both probes, one probe here and one probe this side, you get a value in multimeter. If you get a value, then the resistance is okay after installed it. Because when you get 1.8 volt here in this battery connector Batt ID line, that means the power IC line is 100% okay. Power IC line will be okay because you get 1.8 volt. If you get diode value here, this line connected to the 2 IC, between 2 IC, this line connected between 2 IC. If you get diode value also here, this diode value sometime belongs to the power IC, the CPU side line sometime open, so you get here only power IC diode value. You think everything will be okay. For that you check must here the CPU sense, the CPU will be connected to the battery connect, right? After you get diode value, first you check diode value, after you check 1.8 voltage, after that you check this resistance and diode value here. Number 4, if everything will be okay here, check this resistance on which mounted on a battery, right? Now you can check easily this resistance or this resistance through multimeter, one probe on a multimeter right side and one probe on a left side and meter on a ohms mode, right? You get a value, simple. But how we will check this resistance a simple method for check this resistance. Meter on a ohm mode, one probe on a battery ground, other probe, second probe on a Batt ID line. If you get a value in ohms mode, resistance will be connected or okay, right? If you did not get here value, it means R2 is right. So this is whole concept how Batt ID line works and how to check it. I'm telling you Batt ID in schematic diagrams in Borneo Schematic, how Batt ID line will work and how to trace it. How to Batt ID line trace in schematics. So I'm already opening the Borneo Schematics. In Borneo, I'm opening Redmi 9A layout and schematics because I'm already show you a layout before. This is for on a Redmi 9A model. How to trace in schematics? Just first of all zoom and find the battery connector. So here is a battery connector CON1601. Just double click it. Borneo had some schematics in Borneo had a problem, could not copy. So just in a schematic, go to schematics and type CON1601. Here is a battery connector, right? First we go to the battery connector. After battery connector, find the Batt ID. Now you can see here this line connected with the Batt ID test. Here is a Batt ID test point TP. Now another line Batt ID. Also this line connected to the VIO 1.8 volt with 200k resistance, right? I will show you already. Just like here, this line connected between 200k resistance, one line on a Batt ID line and other VOI line connected to the battery connector. If you copy this, so this is the output line of PMIC. So voltage comes from PMIC to Batt ID line, right? Here keeping with the 200k resistance, right? One line connected with the power IC, a line voltage comes from power IC, and this line connected to the CPU. I will show you. Go to the schematic. Now copy the Batt ID line. Next, now this line and battery connector. Next. So this line, there is a TP 3014. In TP test point, you can check the VIO voltage, also a diode value, right? Now next, so this line goes to the AIC. Which IC is this? Just MT6762. So this is CPU. I will show you. Just zoom it and U901. Copy it. 6761 CPU number. So just copy it and paste in layout. And paste in layout. Could not find. No matter. Borneo had some problems. Zoom out and check U901 on motherboard. Second side, you can see here is CPU, also connect RAM. So you can CPU number U901. So this line goes to the CPU, right? Now before it's going to the CPU, focus the line. Where is Batt ID line? In between a cap. If this cap short, this line short from CPU side, right? Also again copy this Batt ID. Now a resistance 1602. 2.2k resistance. Now let's talk about Batt thermal line, right? In a schematic diagram, we can call also a baton, right? Batt thermal, NTC and thermal. These all are names of Batt ID, Batt thermal line, right? In a schematic diagram. Now this line connected to the power IC, right? In this line, we can get 1.8 volt to 2.8 volt. This line also working on a divider circuit as like a Batt ID line, right? According to the divider circuit, we need two resistance. So this resistance, it's our R1. So this resistance 100k, it's our R1. R2 is mounted on the battery strip as like Batt ID resistor. One side connect with the ground and other side connect with the battery temperature line or BTAP line. You can say baton line. when you connect the charger, you will get 1.8 volt to 2.8 volt on a battery temperature line, thermal line, right here. When you connect the charger, this whole line become 1, right? Suppose this is also a 100k resistance, this resistance. So if you get in this line a 1.8 volt, if you have 1.8 volt, then after divider circuit work, you will get 0.9 volt. If you get 2.8 volt from PMIC, after divider circuit work, you get 1.4 volt, right? Now, what is the difference between Batt on and Batt ID line? Difference between this resistance is in thermal line used as a NTC resistance. Now, what is the NTC resistance? I will explain you. NTC resistance means a thermal sensing resistance, temperature sensing resistance, right? Now, when temperature increase, the resistance decrease. If you use NTC resistance, temperature increased and the resistance decreased. For example, in a 40 degree temperature, suppose a resistance at 10k value in normal value. Now when temperature increased to 45 degree, this resistance could be decreases value to 7k. In 50 degree, it should be 5, right? Other side, in normal, if you use a normal resistor on a 40 degree, it's 10k. On a 45 degree, it's still 10k. On a 50 degree, it's still 10k, right? But NTC resistance decreases value when temperature increase according to the temperature. That's why we use NTC resistance in a thermal line, because in a fixed battery phones, when temperature increase beyond to the limit, battery swell or other battery protection or circuit protection, we use a NTC resistance because it's a thermal temperature sensing resistance, right? I will show you. Now suppose this resistance is 100k, this resistance is also 100k. Now suppose this line had a 2.8 volt, right? When you connect to the battery in normal condition, normal temperature, we get 1.4 volt output, right? But if this line had something happen or temperature increased, so we can call, if temperature increased, this resistance decreases value to 90, 80, 70 or 50, depend on a temperature. Suppose this resistance decreases value to 50k. Now what will the effect in a circuit? So our formula is voltage out equal VIN multiply by R2, right, divided by R1 plus R2. If you have a calculator, please calculate yourself. Our voltage in is 2.8, right, multiply by R2 value is 100, right? Now R1 is 50, in temperature increase, it decreases value, so 50, 100 to 50. Now R2 is 100, now equal 280 multiply by 150, right? We get 1.8 volt. 4, we get 1.4 volt. Now we get 1.8 volt. After the 1.8 volt, this line here, a Batt on line through sense power IC, temperature increased because divider circuit temperature above to the 1.4 voltage, right? First we get 1.4 volt, after we get 1.8 volt, right? Because the software in a phone coded such a way that if the voltage is above 1.4 volt or below 1.4 volt, this is just an example. The software in a phone coded such a way that if the temperature above 1.4 volt or below 1.4 volt, then temperature error will be appear in a screen, right? Phone temperature is too high, phone temperature is too low. I'm explaining with another example. Just a second. Suppose this IC working on a 40 degree temperature. If temperature increase, this IC shut down automatically, right? For this IC use a divider circuit. Now R1, R2 and R2 will be attached with the ground. Now this R2 use a NTC resistance, a thermal resistance. Now in a normal condition, the output 1 volt. This IC also sends a output, so 1 volt in a normal condition. But when temperature increase, suppose 40, 42 degree, 45 degree, suppose this resistance, if 100k, it's to 50k, decreases value, right? Then output will be 1.2 volts, suppose. So this IC sense something is happen, temperature increased, something happening in temperature line. So this IC sense that and shutdown is work. But if we use, suppose if we use in normal resistance, right, here in an NTC resistance replaced to a normal resistance, then what happen? If temperature increase to 45 degree, this resistance remain 100k. if temperature increased 50 degree, this resistance remain same value 100k. Output will be 1 volt. The IC sense that everything will be okay, no temperature issue. IC still working, but the temperature creates some issue. For this, IC may be burn or short itself, or the whole circuit will be short. For the protection the circuit or IC, we use a NTC resistance, a thermal sensing resistance. Hope you can understand. Now in this phone you have two lines. From this line you get a battery connector voltage 1.8 to 2.8, right? From this line this IC sense the divider circuit output, right? In this line you have 1k. So if you had a problem in this line, first you get a diode value check after voltage first before without the battery, with charger connect, after with battery. After this you can check this main NTC resistance or this resistance. If this resistance open, it means this line had open. If everything will be okay, this resistance whole this line okay, divider circuit working, but this resistance open 1k resistance, PMIC can't sense the temperature. This lies for this, it will show a temperature message. For this you can check everything one by one. First check the diode value here, after check the voltage, after check the this resistance R1 and R2, also this resistance. After this some time this IC, under the IC these both points are dry or IC internally damaged, so replace the IC in last. In a Samsung, if you had a Samsung phone come to you for same temperature error, you just replace the subboard or charging flex, your issue will be resolved. Why? I will show you, I will explain you. Just now how Batt thermal line work in a Samsung. Suppose this is a main motherboard, right? This is a PMIC, this is CPU, battery connector, sorry, charging connector, this is charging flex, these are subboard connector, and this is our circuit R1 and R2, right? A VIO voltage goes to the 1.8 charging connector, through charging connector belt goes to the subboard, right? A subboard connector through this line goes to the connected with the R1. Now R1 had 1.8 volt from main motherboard. This resistance R2 connected with the ground. Now divider circuit works. The output will be emerge in between R1 and R2. Same goes to the subboard connector. After the subboard connector, same charging flex through the main board motherboard connector. Through this line connected to the CPU. The both line are separate. This line calls name VBat, right? This line is VIO voltage, this line VBat. So CPU sense through this line how schematics, how temperature line works. If temperature increase or in normal condition, right? If this divider circuit had some issue, suppose this line had 1.8 volt, so the both resistance are 100k, so this line had output with 0.9 volt. This line give output to 1.2 volt, right? The CPU sense something happen in temperature line, temperature increased, so CPU show in a phone screen temperature error, phone temperature is too high or too low. If this line, suppose this VIO line is break, this issue will be create. So check this first VIO voltage on R1, right? If this will okay, otherwise check the connectivity between charging flex and the connector. Second, check the output voltage here. If the output voltage you will get okay, otherwise check the both resistance. If you get the output voltage here, check the connectivity between on the motherboard side. After the check the CPU nearby a capacitor. I will show you in a schematics diagram, right? So let's go to the schematic. First we go to the, I am opening a Redmi, sorry, I am opening a Borneo. In Borneo I am open two type of models. First Redmi 9A, second Samsung 125, Samsung A12, right? In Samsung, first I am explaining the Samsung. Now in Samsung I am opening two layout. first layout on subboard of a subboard, second layout a motherboard, and third is schematics. Now first go to the main layout. Now find the charging connector. So here is the charging connector, right? Just copy it and paste in schematics. Now here is charging connector, right? This connector also attach with the display. See, both charge subboard also a display connect with the both connected with the same connector. So in this connector, first you find the B tap line. Now where is B type line? B tap, B thermal, Batt thermal. So here is Batt thermal line, right? Now just copy this line and next. First this line goes to the a divider circuit, but before the divider circuit we see this line goes to the which IC. Now a connector also at thermal. So this line first goes to the AIC. Now which IC is this? U400. Just copy it and paste it in layout, main board layout. Which IC is this? Can't match, so find it manually. U400. So here is this are CPU, right? This is our CPU here, U400, right? I'm explaining in the block diagram. This line connected with the CPU. Now next, just a second, schematics. Go to the back to the schematics. Again go to the Batt thermal line. Just copy it. Next, back to the connector. After this connector, this IC, same CPU, this connector. Now this line connected with a divider circuit, right? Batt thermal. Now in this divider circuit, a line come from 1.8 VDD. This is a power IC output 1.8 voltage, right? Now this is our R1, this is our R2, right? Connected with the ground, right? In between R1 and R2, a output line emerge called Batt thermal line, right? Now where is R1 and R2? First delete is this and just copy and paste in layout, main board layout, paste it. Now match, just again copy it, subboard layout, paste it. Just zoom. Now you can see here two resistance TH1000 and R1012, right? Same in a schematics. Go to the R1012 and TH1000. The both resistance R1 and R2 in a subboard, right? Now I'm explaining in a block diagram already, but I'm explaining here also. Now back to the schematic and copy the just bad thermal line again. So now this CPU, right? First CPU, second a connector, main connector, again CPU. Now this connector, where is this connector? CN6000 and layout, just paste it. Just next, this is a main board connector. Sorry, bad thermal line, copy, sorry for that. First, and now next it will go to the divider circuit. Again SOC1000, another connector. Just copy the layout and paste it. Now, so this is our subboard charging connector, right? Now I'm explaining again in a block diagram. Through PMIC, a VDD 1.8 line through connector goes to the R1, right? Here I will show you. These are bad thermal line. So this is our circuit. A VDD 1.8 AP. This line through main board, right, goes to the R1012 connected with the connector. Here a 1.2 line through this connected with the R1, right? After this divider circuit works, right? Now VTAP line, battery temperature line, emerge between R1 and R2, goes to the subboard connector. After this main board connector, after the CPU. I'm explaining again. So copy the bad thermal line, right? This is CPU through main board connector. This line main board connector through CPU, right? If you add 1.8 volt, after divider circuit in this line 0.9 volt. CPU sense everything will be okay. If this output line increase the voltage 0.9 volt to suppose 1.2 volt, CPU sense something will be happen in a temperature line, so we create temperature pop-up message in your display, right? Now I'm explaining the other Redmi circuit. Just delete it. Now goes to the Redmi 9A. So this is Redmi 9A layout. This is Redmi Schematics. Batt ID line. Already you see Redmi 9A. Just copy the connector. Could not copy, so just paste it. So this is our battery connector. If you type the CON 1602, you goes to the battery connector. I'm already type it. So in a BAT, this is our BAT ID line. Now I'm explaining already. Now go to the BAT on. Now in BAT thermal line, connected with the three lines: BAT on, test, right? So this line goes to the test point, right? Now these two lines, temperature reference, PMU and BAT on, I will show you one by one explaining. First, BAT on test. So this line goes to the TP, right here. Just copy the TP and paste the layout. Can't find, so find it manually. Where is TP 3013? So here is TP BAT on. You can see BAT on 3013 TP. Now in this TP you can check diode value, also a voltage with battery or without battery, right? Now go to the schematic. Next, now this line had a T reference, this line had a 100k resistance, our R1. Just copy it and next. This line goes to the AIC. Now which IC is this? MT6357 CRV. So this is our power IC, right? I'm already show you in a block diagram. Now just again copy this line. Next, and this line BAT on with 1k resistance. This line goes to the test point. Which IC is this? On a BAT on line in a charging section. MT6357, same IC, right? I will show you already in block diagram. Here TRF temperature reference line with 100k resistance. Through this line 1.8 or 2.8 voltage goes to the battery connector. After divider circuit works, through this line power IC sense whether the temperature issue, if the temperature issue, through this line PMIC sense temperature, divider circuit working properly or not, or any kind of temperature issue or not, right? Now this is how BAT temperature line works.